welcome to our series of solving HC Verma one question at a time. Today we have a question, a very hypothetical question which I don't think so can happen in real life, that there is an imaginary atmosphere in which the air exerts a small force F on an particle in the direction of the particle's motion. Like in general, if a particle is going upward, the force of air, suppose this is air, it will just make a resistance for it. But in this case, it is giving the force in the direction of the particle's motion. A particle of mass m is projected upward, takes a time t1 in reaching the maximum height, and t2 in returning to the original point, right? So for solving this, we will have to make two equations. First, it is going upward. So final velocity is 0. V minus u is equal to at is the equation, right? U is the initial velocity given. Acceleration in this case will be g is negative, so minus g, and a force F is in the direction of motion. So F upon m will be the acceleration upwards plus F upon m into T1. So U is equal to g minus F upon m into T1. Let's just move it to a side real quick. So T1 is equal to U upon g minus F upon m. Let's calculate for T2. In T2, the final velocity is V and U is 0. So we don't quite know the value of V or the value of U, but we will just create the equation because it is an MCQ. We don't need the whole solution. We just need to know the understanding, right? So in this, acceleration is in the direction of motion, gravity and this force both. So G plus F upon m into T2 is equal to V. So in this you can see T1 is inversely proportional to this, but this force is decreasing the denominator. When the denominator is decreasing, the whole value increase. This value, when we move it here, V by G plus F upon m is equal to T2. This when increase will increase the denominator, which will decrease the total value. So T1 is greater than T2. Here is your answer. Thank you for your time.